for this report, title is Diffractions of Fresnel and Fraunhofer. And then I am Isaac Chow, Sunkit. My ID number is HA18016. So for introduction, this project is actually a scientific demonstration about the Fresnel diffraction adjustable slit, which this video is actually found from a lab demonstration that obtained from MIT Open Courseware YouTube channel. So this is about with the theme of polarization of light, and there's three main topics that we are going to further discussion, which is the demonstrations of Fresnel diffraction by a fixed slit and also a adjustable slit, and we will do the observations of the transitions from Fresnel of Fraunhofer diffraction to by using an adjustable slit. So for the methodology, first we will set up the Fresnel diffraction as shown as there's a white machine with laser, then output the two mirror and lastly to the short focal length lens and to the screen. So firstly, we have to prove that the first mirror is working with a white paper, and the second mirror is working, and finally the third mirror is actually reflected the laser to the short focal length lens. So when the beams go through the lens, actually pass through the pinhole and be centered the focal spot, whereby the lights will come out from the pinhole and show in the paper. So for as shown in figure 6. So for figure 7, the laser beam will finally show on the screen, and the pattern should be shown on the screen as well. So next, figure 8, we need to put a single slit at front of the laser beam, and figure 9, we need to adjust the spacing of the single slit, and as shown in the video, is we started with the Fraunhofer diffraction pattern. So for figure 10, show the Fraunhofer diffraction pattern, okay, which it's shown that there is a huge fringes focus in the middle, whereby there is a slim oval shape and other small similar fringes mirrored on both sides with decreases intensity of light. So for figure 11, it shows that the increment of Fraunhofer patterns to the side when the spacing of the single slit decreases. So for figure 12, it shows that the increment of the spacing, whereby the Fraunhofer pattern is actually converged together, okay, and form a high intensity of brightness for the focus oval shape fringes in the middle, and also some mirrored fringes at the side, okay, in decreasing size. And then the demonstrations of the Fresnel diffraction by a fixed slit is starting when with a middle, okay, of a dark region. So next, for the Fresnel diffractions with an adjustable slit, we can show that when the distance of the single slit is increases, okay, there is two dark region at the middle of the fringes, okay, and then for figure 15, we can show that when the distance of the single slits increases, okay, the fringes will then increases too from the middle, and the greater the diffraction pattern will be diverged until it's unobservable. So the experiment above is undergoing in a bright light room. So next we will try to turn off the light and compare the difference. So now we will start from Fresnel to Fraunhofer diffractions by using adjustable slit. So firstly, you can see that it's hardly to resolve by eyes, since there's a lot of small slit separations, okay, at the Fresnel diffractions pattern. So on figure 17, when the distance of the single slit decreases, you can see that there's decreases of fringes, and then for figure 18, it decreases until two dark region in between, okay. It's also results from the movement of diverging of the Fresnel diffractions pattern, okay. So when the distance keep decreasing, okay, it's actually reached the ending of the Fresnel diffraction, whereby there is only one dark line in the middle. Then figure 20 show the starting of the Fraunhofer diffraction, whereby the slit is decrease, okay, whereby when the slit keep decreasing, the fringes will converge together and form a brighter fringe at the middle. So figure 21 shows that there's a bright big fringe in the middle, and the mirrored side of fringe keep increasing at the side, okay, with a lower brightness. And then obviously the observation in dim room is better than the bright room, and most important is if we need to observe the contrast between the dark fringes and the bright fringes of the Fresnel diffraction pattern and also the Fraunhofer pattern, okay. This is very important to calculate, okay, the spacing between the fringes, because the spacing between the fringes decreases, the center between the two slits, okay, is also measured and used in the calculations.
So now come to the conclusion. So this is actually a lab demonstration that we take from the YouTube, and it's a transition from Fresnel to Fraunhofer diffractions by using an adjustable slit, starting from the biggest distance, then very short Fresnel diffractions pattern with multiple fringes in the middle of the pattern. Then when the distance of the single slit keep decreasing, the fringes is converged together and form bright fringe in the middle, which is then the initial of the Fraunhofer diffractions pattern. So hereby the fringes will diverge from the middle of the fringes and form multiple lower brightness mirrored fringes at both sides. So that's all. Thank you.